The AI revolution isn't just about bigger models. It's a fundamental shift from renting intelligence to owning the compute that runs it. OpenClaw and similar tools signal the end of cloud first as the default for serious engineering work. If you build your next autonomous agent on public APIs alone, you are engineering for high latency costs and privacy leaks before writing a single line of business logic. Today, we connect this headline to the critical trade-offs between local inference and cloud dependency that dictate whether your system works in production or fails at scale. When a new AI tool drops, the question that matters is not how large the model is. It is where that intelligence lives and what it costs you every time it needs to make a decision. For years, engineers have assumed that sending data to the cloud was the only way to get fast results. They treated local devices as too slow for anything beyond simple commands. But this assumption is breaking down under the weight of real-world requirements. The bottleneck in modern AI isn't model size anymore. It's that we are applying cloud-optimized generation logic to edge devices where prefill operations or the initial processing of a prompt are just as expensive as decoding tokens. Consider the difference between running a chatbot and building an autonomous agent. A chatbot asks for text and gives back text. An agent checks your calendar, reads files, and executes commands. When you send this workflow to a cloud API, every single tool call introduces latency. The system waits for data to travel out over the internet, gets processed by a remote server, and then travels back. For an autonomous assistant like OpenClaw, which aims to be everywhere on any platform, that round-trip time adds up instantly. Research from KAIST proves this structural flaw clearly. In their study of local agents, they found that while clouds struggle primarily during token generation, local inference faces unique bottlenecks in both the initial prompt processing and generation due to limited hardware resources. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The good news is that local is slow is an outdated assumption for anyone with a modern machine. By optimizing specifically for these edge constraints using techniques like prefix caching and LLM-free speculative decoding, engineers have achieved a 1.61x speedup on end-to-end agentic tasks without losing accuracy. This means your personal AI assistant can now respond faster locally than it could by waiting in line at a cloud turnstile. The hardware constraint is no longer a hard wall, but a variable you can tune through software choices like quantization, which compresses massive models to run efficiently on consumer RAM. This shift reveals why the choice of compute architecture must happen before your first feature is built. As AI moves from simple chatbots to agents that interact with calendars and files, sending data to the cloud becomes a liability rather than a convenience. Tools like OpenClaw demonstrate that developers can now run GPT-level models entirely locally using standard service APIs without any DevOps overhead. You are not just running code, you are building a private server room in your basement where user data never leaves the device. This is the critical distinction between renting intelligence and owning it. The engineering reality here is stark. Relying on cloud APIs for autonomous agents creates vendor lock-in that scales linearly with usage costs, but exponentially with risk. Every time your agent uses an external tool, you are exposing sensitive information to a third party. Moving to local inference via tools like OpenClaw shifts the cost from recurring API fees to a one-time hardware investment. This fundamentally changes the unit economics of building AI products. You stop paying per token and start paying for the electricity to run your own machine. We see this capability expanding rapidly across different platforms. The ability to run massive models on consumer hardware, such as running Qwen 3 VL with 32 billion parameters on an Apple M-series MacBook Air using specific quantization flags, proves that local inference has outpaced expectations. This isn't magic. It is the result of aggressive compression techniques and specific inference settings that standard wrappers often hide from you. The gap between what a developer needs to run advanced models and what they can actually achieve with open-source tools like llama.cpp is closing fast. However, this transition requires a new kind of engineering judgment. Native integrations in many popular home automation systems currently lack support for these advanced local inference servers. Users often have to choose between limited wrappers that restrict their capabilities or complex custom setups involving specific flags and configuration files. This forces developers to make difficult trade-offs about how much complexity they are willing to manage versus the control they gain over latency and privacy. The choice is no longer just, can I run this model? Because the answer for most modern hardware is yes. The question has become, do I need the cloud for my specific workflow? For agents requiring high-frequency tool use, local compute is now the superior engineering solution. If you are building a system where speed and data sovereignty matter, waiting on an API call is no longer acceptable. You must design your stack to keep intelligence close to the action. This means understanding how quantization affects model accuracy, knowing which flags optimize for pre-fill latency, and selecting hardware that balances memory bandwidth with processing power. The future of development lies in this any OS promise. The ability to run these powerful agents on Raspberry Pis, Mac Minis, or gaming PCs means the barrier to entry for building private AI is lower than ever before. You are no longer dependent on a single vendor's infrastructure to deploy your most critical tools. By shifting from cloud dependency to local inference, you gain control over latency, privacy, and cost simultaneously. This is not just an upgrade, it is a fundamental rethinking of how intelligent systems should be built for the real world. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.